Keep up the good work, man, and stay flat, okay?
Okay, I'm a flat earther.
Hello, everybody. Hope you're doing well. GE, kick us off, right?
What's up, heathens? How ya doing?
Us heathens are doing fantastic.
Yeah.
IL, I believe is. I hope I'm saying your name correctly. I sent the link to join in your email. I haven't received anything back from you, so I'm hoping that you get that if you are watching, wondering where that's at. I don't know if I sent it to the right email, but if not, and you're in the chat, make sure that you let us know so that I can be made aware of that. We can send it where it's supposed to go, because I need to make sure that that gets to you. And if for whatever reason something happened, that's completely fine. GE and I we have something we're gonna talk about first, and then we'll open up the room. But if you are watching and I sent that to the wrong place, please tag me and let me know. Okay, GE, how's it going, man?
Yeah, it's going okay. I do have to ask though, with the nun bot, what can you redeem? Everybody's been trying to figure out what exactly you can redeem. Is there like a list that we can get somehow?
There will be,
Shit
yes.
you can redeem?
I'm in the middle right now of coding that store for the scripts.
Okay.
You'll be able to redeem it for things like super chats. Like if instead of paying for one, you can just redeem it and send that in. You'll be able to redeem merchandise. Things like being a part of a after show, because they're limited in like the numbers that we can take in. So if you want to make sure that you actually get into one of those, you can buy a spot on that. Just random stuff like that. There's you'll also be able to like redeem it for things to make me and Steve do stupid stuff, when we're on, or maybe even me and you when you're on here. Some people do like they'll take super chats to take shots or whatever. That might be fun to do one night. You can just redeem your point.
Yeah.
You should have a couple of requests for Godless Engineer on the ukulele. That's what you should have in there too.
That would be fun. Yeah, that would be fun too. That would be fun.
But I would not be showing my giant penis on camera. So y'all can just not ask for that at all.
Damn it! Somebody in the chat says, "Can we redeem it for Kyle's used socks?" Oh my God, no. But if you are interested in that sort of thing, I believe it's Mr. Repsion that does that. You can go to Mr. Repsion's YouTube channel and.
Kyle, you should really start an Etsy store for that.
No, I couldn't do that. No, that freaks me out. No, that freaks me out. You can code. Kyle, you do everything. I'm trying to learn. I've been trying to learn code. It's something that I'm new to. 82 Japanda says, first live stream I wasn't at work for. I'm so happy. Hi, GE. And then Sadie 79 says, hugs to you too. So once again, I don't know. I spoke to the guy that is going to come in, and he actually works for an organization that sets beacons out in the ocean and actually counts on the Earth's curvature and how that fluctuates to quantify data and stuff like that. So it's really interesting. He's in Germany, and we spoke earlier. If you're watching, email me at live@nonsexshow.com and make sure that I sent the join link to the right place, because I haven't heard anything from you since we talked earlier. I knew we were good to go then. So if I send it to the wrong place, let me know, and I'll make sure that we get it to the right place. In the meantime, though, GE, you watched Logan Paul's video, right?
Oh God, yes, I did. Casey and I have a whole Twitter thread about it.
What was your takeaway? Because to be honest with you, I haven't seen it yet.
Oh, have you not?
No.
Well, my takeaway is just one big long troll. Like if I could sum it all up in one word: troll. And I have to say, he's probably the perfect person to do such a deep trolling of the flat Earth community, because I mean he barely has enough brain cells to not be a flat earther, as far as I can surmise.
I saw him in a the one like image clip that I've seen from it that I just think pretty much would sum up the whole thing is him sitting at a little desk with I believe it was a little girl, like at a school desk or something like that.
Yeah.
What's he asking the
Yeah, there was
kids?
that. Well, he was asking the kids, like, do you think that the Earth is a globe or whatnot? And so they go through a bunch of kids. It's like, no, I don't. I mean, the Earth is round. Like, he went through a bunch of kids doing that, and then finally it came to a kid who was obviously acting, and
Mhm.
he was like, do you think the Earth is round? And the kid's like, nope, it's flat. And then he brings out a globe, and he has the kid knock the globe off the table, and he's like, that offends me.
It's actually funny.
But like,
It's actually funny.
yeah, but like, so the biggest indication that it's all a troll, is not just like the obvious scripting of the scenes, but the fact that like they sit down with his friend Mike, who's supposedly a
Mhm.
flat earther. They sit down with him, and he starts talking about how he lived in Antarctica, and his friend fell off the edge of the earth, and
What?
he starts crying about it. Yeah.
Oh my god. I wonder how many I wonder how many people watch that and honestly believe that story. You know?
Yeah, I don't know. I don't know. Like, I feel like even flat earthers at that point would be like, "Oh, he's just trolling us. Nobody can go to Antarctica."
There's a I saw an ad for a flat Earth cruise that's taking place
Oh God,
uh,
yeah,
in the summer. I think that's amazing. That's absolutely amazing.
yeah.
Okay.
I can't believe the lack of brain cells that will be on that particular ship, because most people, most flat earthers don't have two brain cells to rub together. But I mean, the lack of intelligence that's going to be on that, like, I would hate to see what's going to happen to that ship if it like gets stranded at sea for like 4 months. Like, I would
Cool.
just hate to see like the panic and confusion on that particular ship.
I real quick, I just talked to I just heard from back from IL. He is good to go, I think. And I'm gonna
Yeah,
resend
he's
him the
attempting
link
to
to
log in.
Oh yes, okay. Okay, good. Perfect then. If there's an issue with vmix, Dave, I'm gonna send him your Skype name. Maybe we need to bring him in on Skype. Maybe that's the issue. Let me do that real quick. Okay.
Yeah, I typed in the chat, so I don't know if he'll see that or not, though.
Okay. I just emailed him. So if you are listening to the chat, sometimes like I don't know, there's some instances where it won't. People can't connect to vmix for whatever reason. In order to, yeah, yeah, and to avoid all that, having to go through that and put that together. If you'll just add the name that I just emailed you on to Skype, Dave can bring you in, patch you in through Skype, and that will just be the way to go. Uh, do you know, Gauss Engineer, if Globebusters has come back yet? Is their channel put back
I don't
together?
know if well, yeah, I don't know. I haven't seen anything by them. I think that they're still working out copyright issues and stuff.
Okay. Um, let's see. Yeah, just add that on Skype, and we'll get you through here. Sorry about this, guys. It's only one of those things. We wanted to go live either way, whether or not something had, a miscommunication error had happened or whatever. But we were going to open up the room. But let me just give you a little bit of what's going to happen tonight. There's a common line that's put out there. And GE, how many times have you heard this for a reason that the Earth is flat? that water always finds its level. The water is flat, the oceans are flat, therefore there can't be any curvature.
I mean, that's a pretty standard, like if you had to ask any flat earther for like their number five, like 5 reasons why they think the earth is flat, that is definitely going to be up there at some point.
Mm-hmm. And there's 2 things about it too. Water may find a level, but level doesn't equal flat. That's the
No.
the mis.
Yeah, see, I mean, level is just perpendicular to the force, like at which it's being affected or whatnot, and so that's all level is, and it's very I guess local to where it is, because like, I mean, if you could have like one of those bubble levels that stretched over like, I don't know, like 6 miles or something like that, you could probably see like the bubble not exactly be perfect. But then again, I mean, you're talking on scales that are so large that it's kind of like you would expect to see that. Of course, no flat earther out there has like apparatuses like that, and they're definitely not going to invest in that because I mean,
Right.
it's completely ridiculous.
Yeah, I would wholeheartedly agree with that. So since this is a big talking point, we were in a private hangout today with our patrons, and he was explaining what all he did and how he incorporated it with his job, and I just found it fascinating and a good way to show that this line is just complete BS that they give. Okay, Ayel, are you here?
I am. Can you hear me?
Perfect. Yes, perfect.
Oh,
I talk to
great.
you again.
I was trying to connect, with this platform, but for some reason, I think we have these really heavy firewall systems here with Checkpoint, all this military grade firewall, and so it wasn't allowing that port for the camera or for that kind of voice communication. So I'm using Skype on my iPhone. So.
Oh, perfect. Yeah. So that may be exactly what it was. But
Yeah,
why don't
because
you
I think it's
take?
just blocking the port because the screen,
Mhm.
the interface came up and everything, but the interface wasn't able to access the microphone or the camera. So I guess that means the
Yeah, the
firewall's
blue
working.
screen of death. Yeah, the blue screen of death, as we call it.
Yeah.
Phoenix will just if it's not working, it just gives you a complete blue screen with a little box where you can see yourself.
Yeah.
But
Yeah.
welcome.
Yeah. Except for
Welcome
I can't
anyway.
even see myself. It's just a black box. But anyway, we're here. So.
Yeah, exactly. Well, I'm glad that you're here. Why don't you take a second to introduce yourself and let everybody know what it is that you do?
Sure. So my name is Ayal Ram, and I'm with Ram Group. We develop different quantum sensing platforms. So we work with different Group 3, Group 5 nitrides. These are these quantum mechanical crystals. This is kind of like what we call the post-silicon world. These are the materials that are going to replace silicon in just about anything other than kind of like basic semiconductor technologies. And we use them to develop a platform of different sensors. And these are what we call super transducers, where we're able to interact with all the different fields simultaneously. So you can interact with electric fields, optical field, magnetic fields, acoustic fields, and do this in this very causal nature that the data that you're gathering here is causally connected. So the one example I'll give, which is a very basic kind of example, but you'll get the principle. If you put a sensor today, or kind of like the existing sensors, in a, let's say, some type of a vat that is filled with a gas, and then you change something in there to change the pressure, and you had a pressure sensor and you had a let's just say a pressure sensor in there, you would see the pressure changing. Let's say it's at 100 bars and you change it to 200 bars, so the pressure sensor would show you, going from 100 to 110 to 200. However, you don't know why. You don't know if the temperature has gone up. You don't know if there's some chemical process that has caused some proliferation of some interaction of different compounds. So with the type of sensors that we work with, you would have the reading that would say, well, the pressure is going up, but the density or the volume of the gas has gone up, and there's this interaction which has changed the pH, and so this is what's causing, you know, the pressure to go up. So it's this kind of new platform of sensors that move from the what to the why. But you know, I've been watching your guys' show for a while, and specifically this whole flat Earth nonsense. But I've also learned that you have to, you know, be kind of polite because you're really wanting to not get these people defensive, and you know, given that impression that you're just treating them like idiots. So I, you know, was thinking about, well, what is the most basic way to prove in something that there are no points to negotiate on it, the curvature. And so we, you know, what I was telling you earlier in the conference is this project that we're doing out in Indonesia, which is this early tsunami detection. As you know, that there's been some tsunamis out there, and a lot of loss of life. Very, very, very sad. And so the you know, the problem there is, of course, is that you have these waves that are propagating 6, 7, 8, 900 kilometers an hour, so they're difficult to detect. But we came up with an approach of how to do it, and that is by sending different high frequency RF waves over the surface of the water. And over the first 1 or 2 meters over the water, you have like 100% humidity. So it actually acts as this very soft, cushy waveguide for, you know, these RF waves. And so they propagate, and they can propagate over long distances. But that is, again, playing into this whole refraction, diffraction that's happening in what's called this evaporation duct. But when we do this, and when we put an emitter and we put a receiver to measure this, and the reason we do that is because when a tsunami wave comes underneath, it changes the properties of that waveguide. And so if you see that over a vector, you know that there's a wave, you know that there's a energy propagating underneath the water, even though the top of the water only changes by 1-2 centimeters. But when you do that, you have, and I sent you a few pictures, you see this spectra that perfectly correlates to the curvature. And so you'll have these dead zones. And so what I would say in the easiest argument let me back up one point here. So the first point I'm constantly hearing is that, you know, well, there's this refraction, there's this diffraction, it's bending light. This is why you do see things. This is why you don't see things. And so that's kind of introducing a variable that I would say has kind of a high standard deviation. But
let me ask you this, Ayel.
Go ahead.
Let me ask you this. Those pictures that you sent, they're ready. If you just want to let us know, like which, like as you're going along, we can throw up whichever picture you need. So as you get to those, just let us know and we can throw them up on the screen.
Okay. Yeah. Perfect. So just very quickly, let me just finish this point. So you have, you know, everybody talks about this refraction, this diffraction that's happening, but if you look at the whole electromagnetic spectrum, you know, you're talking about visible light, which is starting from, you know, arguably 800 nanometers down to 400 nanometers, which is going into the UV. But that's a very high end of the spectrum. If you go further down past microwave into terahertz or, you know, hundreds of gigahertz, there are a lot of frequencies that don't have any interaction with oxygen or with nitrogen or anything that's in the atmosphere. So there's no absorption, there's no diffraction happening at these spectrums. So if you pull up those the images there, those first 2 images where you see that red contrast.
Okay. Yeah, Dave. The one with the red on it. There we go.
Yeah, there you go. So what you see there is you see the at different frequencies. You're seeing kind of the propagation and the interaction over different nautical mile distances. And so this shows that as you are working down to lower and lower frequencies, and then also at a lower and lower altitude, meaning where the emitter is positioned. So if you look at the y-axis, that's the height, and that's, again, one of these big discussions that I always hear you guys talking about, which is the vantage point of where you're standing. And so very interestingly, if you go, down by meters all the way down to zero, meaning at the surface of the water, and these are, remember, this is not the accuracy of your eye, which is wildly inaccurate. These are, millimeter, wavelength accuracy. So you're seeing the curvature. It's right to say that there's a curvature over 3 miles or over 4 miles, but there's curvature over any distance. It's just very, very small. And obviously, more and more as you get further out. But you can see that as we bring the emitters down to the surface, you can see the dead zones showing up, which is the gray area right there. Now, that's just data that nobody can argue with, because it has nothing to do with atmospheric refraction or diffraction or any other. And this is all over the surface of water. This is not over terrain. This is not over hills. This is not, over any other terrain. And you can see clearly the conforming of water over this distance and how it's bending out, and it's creating these dead zones. And so if you go to the other kind of black and white images there that are at the 30 megahertz propagation.
That one?
Yeah, there you go. So you can see here, and then I sent you a few at different frequencies. You can see also the curvature for this propagation. So when we put a emitter and we emit these RF electromagnetic radiation at these frequencies, you see exactly what would happen if there was a flat line. If there was a flat line, it would propagate exactly to that straight line that's, where you see that plane Earth. And you see exactly where the dead zone, and what you saw in the previous image, the gray area, is between that plane Earth and then the Earth. Right there, it's white, but you could think of it being filled in with gray, conforming to the previous image. And that is that's the dead zone. That's what's happening because the Earth is curved. So this is something that, without getting into, the sun and the size of the sun, and is it moving away, and all of these things about these telescopes, and, how do you move it on a certain axis? All of that is great. But what I'm talking about here is something that would be impossible for any flat earther to interpret in any other way. There is no there's just nothing to discuss here. It is a fact. It is how it propagates. And you can move through some of the other frequencies where we show at different frequencies exactly that same propagation feature. And it conforms exactly to the curvature of water around the globe. And we do it out there in the Asian oceans, the Indian Oceans out there. We've done it out in the Mediterranean areas. We actually did the first prototype over a lake, and did this this first data and the curvature right over a lake. So to me, getting into the visible light, that range, it brings in all of this variability because it interacts with the atmosphere. But when you work with these types of, so when there was that, that Netflix show that, Behind the Curve, whatever, that the hilarious part at the end, interesting, real interesting, where they were trying to use light, I just said, they're using light. That's nonsense. If you want to measure it accurately, in a way that just has no, atmospheric interaction, this is how you do it. And so if it wasn't the case, then I can tell you the cost, because we work with mobile operators here in with Deutsche Telekom and Vodafone out here in Germany, and the cost for a tower, because it has to be connected into either the fiber optic or the cable network, it's extremely expensive. And so if these mobile towers could get more distance, because the earth was flat, they would not be spending tens of thousands to 100,000 for a single mobile tower, just to push forward some flat earth conspiracy. I mean, it would just be ludicrous. And we work with the signal loss on these cell towers, and the signal loss, the dB loss, is it's completely predicted by the distance, and completely predicted by the dead zone. So that was really, to me, the one proof that I'd love to hear any flat earther try to spin, or that's just taking it into this, in the scientific realm, where there's, I mean, there are no interpretations. This is just fact.
You said it just a second ago. You would love to hear flat earther say opposite wise. I don't know if there's any watching, but if you are and you think that you can dispute anything that you just heard, as always, you're more than welcome to come in. But it has to. The catch is that we're sticking to this point about the curvature of the water. I don't want to go into the 9,000 other different arguments. We're talking about curvature of the water, because that to me is what I think the biggest, or the number one argument people put out there for flat Earth. GE,
exactly,
what do you think?
Exactly. That's why
Sure.
I brought this up to you. That's why I thought it was such a good case study, because this is propagation over the water. We study, and here's another tidbit that you can use in kind of your future conversations. There is this evaporation duct that is over the surface of the water. It's the first 1 or 2 meters. It can even be 3 meters, where you have 100% humidity. It's just complete water that is cycling and evaporating into the air and back into the water, into the air, back into the water. So that is what is playing with all these optical wavelengths, these wavelengths between 400 nanometers and 800 nanometers, which is really the visible range. Well, yeah, I guess the older you are, the more limited that visible range is a bit, but that's where you have this whole interplay in bending and kind of light path it changes. But what is so interesting there is that when we recalculate the waveform of the electromagnetic waves that we are propagating, you get and that's what you saw in those red images. You get the perfect reconstruction of that evaporation duct. So you see that evaporation duct, you can almost like really rebuild it in kind of 3D, as it's traveling over the surface of the water, over the water that is curving and going around in exactly, the curvature pattern that you see on the globe. And so you can do this and map out exactly the exterior shape of the surface of the water. It really millimeter accuracy. And so this is, yeah, that's, to me, I think is the big point that I'd love to hear anybody
Sure.
refute.
Breaking down the walls. I saw somebody say that you might be interested in coming in. If you are, then tag Dave in the live chat, and he'll give you a link. Oh, you were joking. Okay.
Oh.
GE, what do you think while I try to see about getting this person in?
Okay. Well, so one common response that I've been seeing lately is that measurements are not science or can't prove anything. How would you respond to somebody telling you, well, this is just all math, or that this is just, you're just plugging in numbers into these equations and that's not science? What would you say to that?
Well, I mean, the first thing is what are we defining as a measurement? I mean, is a measurement a yardstick? I mean, if I put out a yardstick and I measure a yard, did I measure a yard? Well, if so, then using kind of that definition, that term of a yardstick, which I have a physical stick and I measured a yard, math is one thing, but what we do is sensors. And so we are physically out there and interacting and measuring. And if I put an emitter and I put a sensor at two different points over a specific distance, that we can measure in kind of like that same approach as a yardstick, then I know exactly the distance. And so when I measure the signal loss or no signal for a dead zone, there's no, I mean, the math that's involved there is the most rudimentary kind of calculation in the world. I mean, you're just, it's just distance over loss in dB. So there's no math. I mean, there's no equations. There can get equations in doing what we do to detect a tsunami, but that's something else. That's right. We're measuring the properties of the waveguide and getting into something that's much more complicated. But I'm just simply talking about the signal propagation and where the dead zone appears and where you see it show up in just doing a waveform model. Well, when I say model, I don't mean math, because they're going to start saying math again. But you just plot the waveform over the vector and you see it. So, I mean, in our terms, it's working with sensors. So to me, that's not dealing with math. That's not dealing with models. It's a real device. It either detects it or it doesn't. And when you plot these out, this neural net where you have sensors all over the place, you get a very clear picture for where something is and where something isn't, just as basic as a yardstick is.
Mm-hmm. I'm kind of surprised here. This may be the only time we've opened it up, and I know that Flat Earth, also Jesus, and Russian Vids are in the chat. But guys, we've had you on both twice each in the past week, so we need to get some variety in here. But no one, I'm not seeing anybody that thinks that they. I saw a gentleman named Dana that said he could destroy this argument. I invited him in, but he said he wasn't a flat earther. But that doesn't matter. If you think that you can come in and point to where he's incorrect, we would love to have you in. But this may be the only time that I've never seen anyone asking to come in. I think you just killed flat Earth.
To me, it's just the one argument that just doesn't bring in all these other variable points that you can get hung up on, or you can start saying, well, this is some fake image, or you're just working at frequencies that just don't have that. Just from a physics point of view, they don't interact unless somebody is coming and redefining physics. So yeah, I just don't see any way anybody's going to come and interpret that any other way. So it's just it's just how it is.
Well, I mean, you have a lot of flat earthers now that are really propping up like these infrared images that supposedly show a lot more than we're supposed to be able to see on a globe Earth. So, I mean, if somebody
Yeah, but that's
brought that,
1500. Yeah, that's usually 1550 nanometers. So 1500 nanometers, 1550 nanometers. Unless you're going into, kind of the near infrared, still has a very high absorption spectra in atmosphere, in air. So yes, you can see some things better, but remember, your all energy loss, which is essentially translating into heat, is interacting with that. So you're still going to have a lot of noise that is going to interact with that. You can see in some aspects better, but still, you're still going to have a lot of these artifacts, and that's why they don't use infrared in kind of a certain line of sight communications. So there's but there are that's not true. There are some infrared, but going more into microwave, and then some of the things that we're doing, which is UV, but that's separate. But yeah, I mean, you can definitely get a different image, a different spectra at these infrared frequencies. But what I'm trying to do is take the conversation away from this whole kind of visible range, and down to past this, what's called this this terahertz gap, where this waveform duality of electromagnetic waves and photonics kind of merge together, and so you get these really unique frequencies that act in a very very unique way. And so, just to tell you how exacting it is, you could have a wave that's at, let's say, 900 gigahertz, and it's completely absorbed within 20 meters in the atmosphere. And you could change it from, let's say, 900 to 952, and it's able to go several miles. So it's very, very specific in how this dielectric interaction happens with the air. And so, and again, the dielectric permittivity of air is very, very, very high.
Real quick, God, yeah, that was a typo. What you gonna do, M Gold? I saw you wanted the link to come in, and you don't have Skype. Okay, I need your email address so that I can send you the other way to come in if you want to do that. So if you want to come in, send me your email address. Go ahead, GE.
So basically, what you were just saying just now is that this has, I guess, not necessarily a higher resolution, but it gives a clearer picture as to what can and can't be detected at the longer distances. Whereas the infrared, you wouldn't get as clear of a indication. If I'm understanding,
Correct. Yeah, because if you're saying higher resolution, well, the optical, the visible wavelengths are much, much smaller. That's 400, 500, 600, 700 nanometers. So from a resolution point of view, the visible wavelengths are going to be smaller wavelengths, so meaning higher resolution. However, their interaction with atmosphere is very, very high, and they can go through all this kind of lensing and bending and different interactions. And so that's why I'm talking about using, high frequencies. We're doing things in terahertz. Now, there are terahertz that can't go further than 20 meters in the atmosphere, but there are other terahertz frequencies that can go huge distances, and you can actually keep bouncing them off the ionosphere to go halfway around the Earth. So it's really just taking it to a wavelength that doesn't have that interaction, and you can propagate them and measure them really, really well with these very, very sensitive sensors, where, you know, getting into some type of a laser or light that you're trying to measure, that you're just pulsing some light. I mean, it would just be completely lost in the background noise of, you know, whatever light from the sun or from the surroundings.
Okay.
M. Gould, I need to know what you're going to do. You said that you had a way that you could disprove this, and then when I ask you for your email, you're not responding. So either you can or you can't, and if you can't, that's fine. Just don't waste our time saying that you want to come in here. But I think other than that, I'm not seeing anybody with an argument against. Like I said, I think we can safely say that flat Earth died on, what is today? March the 23rd, and you were the person to kill it. Congrats, sir.
Well, anyway, you have my email. It's almost 4 a.m. here, so or 3:15 a.m. So I'm definitely gonna head in. But I really love your guys' show and supporter, and think it's a fascinating subject, but there's just some things that are just in plain sight, you know, no pun intended.
Oh, hey, hold on 1 second. I actually, if you gave me your email, send me an email at live@nonsexshow.com. I never once saw the email come through the chat. Maybe it's filter blocked or whatever, but live@nonsexshow.com, and I'll send you a link. Can you give us like 15 more minutes before you head out? I just want to hear what his argument against is. I'm curious.
Are you
Is that
talking
cool
to
with
me?
you? Yeah. Is that cool with you?
Yeah.
Okay. So email me real quick, live@nonseqshow.com. I'll send you a link to come in, and then we'll hear what you have to say. G, did you have any other questions or anything you wanted to?
Well, yeah. So one of the top 5, I would guess, reasons for why people believe in the flat Earth and they disregard all science is that, you know, they perceive it as flat and therefore it is flat. I'm wondering, how do you think this should affect a flat earther's view on that particular argument? Like, should they walk away from this being like, well, maybe my perception's wrong, or like, I'm just wondering, what do you think of that argument, and how does this factor into that particular idea?
Yeah, I mean, you know, there's 2 ways you can look at it. One is you're, you know, trying to deal with the individual and their own, you know, kind of journey. And then there's the second point, which is, you know, the facts don't really care about, you know, people's feelings or beliefs, which is just kind of a bit of a harsh statement, but it's, it's just how it is. You know, when I went into a few of these chat rooms just to kind of hear what some of these flat earthers were talking about, and I asked a simple question. I said, well, you know, do you guys believe in atoms and, you know, subatomic particles? And the general consensus was, well, we're not sure. We believe in some ether. And as a company that works with crystals, we do, you know, X-ray crystallography all the time, you know, which is again going back to, you know, the days of what Einstein did and proving, you know, molecules and atoms. But you see the diffraction patterns of, you know, of atoms, and, you know, the amount of electrons that are in different atoms, working with gallium and gallium nitride. And so the question is, you know, how far deep does their belief go, right? Is it a flat Earth just belief, but everything else they believe is correct? Or do they come back and say, well, you know, there's no such things as photons, there's no such things as electrons, there's no, you know, I mean, because in that type of discussion, I think it's quite impossible to, you know, to see, you know, where they would go. But if there's a general consensus on, you know, everything, except for what their perception is and the way that they, see things. At that point, I would say, well, look, here's some basic science that you can look at, you can study, and you can see why this is foolproof. There's no given interpretations to this. The data that as we say, the data doesn't lie.
Mm-hmm.
Right.
Okay. The link has been sent. To the Dave, has he logged in yet?
Doesn't look like it.
No. Okay. All right. Cool.
Check your email again and use the second link.
Yeah. How long have you been doing this, IL?
Well, I've been in high tech for I don't know, 19 years, and this company we founded in 2010. So been doing it for a bit. My original background is in computer science. As originally as an Israeli, we have to serve in the military there, and so I was able to go into Mamram, which is the computer intelligence division there. But
cool.
Nothing to do with the military, or I don't know what some flat earthers are going to start thinking conspiracies. It's just Israel.
Oh, yeah.
We all have to serve when we're 18. Doesn't do any indoctrination.
Russian Vids is in the chat. I'm sure that you're by the time it's over, you will be a part of every conspiracy known to man. It's usually what happens with him.
Well, I mean, anyway.
Is he in, Dave?
No, he's actually having trouble logging in, so I don't think he's able to log in with vMix. So
And he doesn't have a Skype. Well,
and he doesn't have a Skype. So
yeah, it wants a yeah. You have to have a you have to have a camera. vMix has to pick up on a camera. You don't have to have the camera on. You just it has to be able to detect one. That's just part of the way that the software is set up.
And you have to use Chrome. You have to cut and paste the link into Chrome. You can't just click on it. It won't work from Facebook Messenger or Gmail, for that matter, usually.
Yeah. So I guess you said you would be. I know it's late where you are, but you said you would be interested in coming back too. Maybe we could that way we could actually set up something between you and someone else can come in and give their kind of grievances and make sure that we because we just kind of opened this up tonight, but maybe we can do that.
Yeah, absolutely. Not only that, we're constantly doing all kinds of pilots, and so I could almost see a situation, just because I this is just kind of fun and interesting to me, where we could do some specific tests and also discuss the data in kind of a interactive.
Sure. M says, hold on just a second. I'll give you 2 minutes, M Gold, if you think that you can bypass the camera thing, but it's extremely late. He's on the other side of the globe, so I want to make sure the globe. The globe.
Yeah, and it's dark here, and I can't see the sun. So.
Yeah, well, they just turned off that light. They got to recharge.
Yeah.
I'll give you a couple minutes, and then we're gonna let him go if you can't make it in.
Yeah, I mean, and that's the other thing. I mean, I just don't even understand the whole thing of the sunlight, because if it was just one projector moving around, then where does the whole red shift and blue shift come in? It's just the laws of the sun and all of these different constants would just have to be completely violated in a way that our own universe and the constants we have would just be so violated, nothing could exist. I mean, the weak force and the nuclear force and the strong force, they would all just be completely violated with how they're saying the sun is behaving.
Mm-hmm. I agree. And how much does
I
the
mean,
power
there's
bill, you
just
think?
so many different constants that would have to be
Mhm.
completely violated.
Yep. I agree. There's you could go off on all kind of rabbit holes with some of, like, the whole droppity thing is my favorite. Droppity is pretty much my my favorite word. I don't think IL he's going to be able to make it work. So we'll go ahead and let you go because I know it's late. Thank you so much for coming in. This was absolutely fascinating to hear. GE, do you have anything else that you want to ask him before we?
You bet. I'm
take
a fan, and yeah, you guys keep it up, and we can set up a time
Sure.
to do this, and I can actually probably put some better slides. I mean, this was all kind of last minute, so
It was very last minute. GE, you have anything else?
Not really. I mean, I thought that this was a very interesting presentation, and I had never thought about, like, this particular attack on, globe denial. And I thought it was very interesting to hear about this, to see the actual data. Of course, like, the main thing with flat earthers, though, is that they deny any evidence that goes against their narrative. And so, like, you could throw this out there and they're just gonna, like, Flat Earth Jesus in the comments. I mean, he was just totally disregarding this entire argument, saying that it's all nonsense and that you can't measure, what was it, diminution over distance or something like that. Like, they're always going to find a reason to reject good
you can't
explanations.
measure what over distance? What? Kyle,
He was saying diminution or something. I can't remember exactly.
Yeah, Flat Earth Aussie Jesus, what did you say? You can't measure what over distance? Diminution.
Sorry. I've had
Yeah,
a little
so
bit
he
of
said so you can't measure loss. Yeah, I mean, if that was the case, man, where would one start? If that was the case, all of these Doppler shift systems, these optical Doppler shift systems wouldn't work. It'd be interesting to see how these planes coming into runways at such frequencies wouldn't be smashing up against each other every day. I mean, yeah, it's
he says shrinkage. That's the word he was going for. You can't measure shrinkage over a distance.
Yeah, I mean, is this some new technical term?
It has to be.
So, I mean, I guess maybe after a cold shower in a cold bath, maybe you can measure shrinkage. But
oh, nice way to I was thinking that. I was thinking about making that joke, but I was like, you know what? That's what people expect from me. So I'm glad that you made it.
Well, I mean, it's just, what does that mean? You can't measure shrinkage. I mean, is he referring to the red shift and or blue shift of? I mean, because at these distances, that the distance, that the change in the distance that light has traveled, which is assuming that at the Planck's length, which is going down to 10 to the minus 45. Light is traveling over a longer distance, but yes, correct. In that aspect, to measure the difference in distance traveled at the quanti size is correct, is insane. But I mean, that's completely irrelevant, and I just don't see what that has any relevance with measuring propagation of electromagnetic waves. I mean, it's ridiculous. We can do it at incredible accuracy.
Hello,
and we can measure even just the humidity change in the air and the shift of that. And I mean,
who's here?
There's so many other things.
hey guys, did I get in or not?
Who is this?
Is this the M. Good?
I'm good. I'm Goudsmits. Godless engineer, you don't know me?
Oh, you
No.
sound fun. So what's your we got to make this brief. What's your dispute with anything that IL has said tonight?
Except that I'm also a glober.
Mm-hmm.
Much of what he says.
Okay. In what way?
Well, he talks about what was it? The devices, terahertz and terahertz, as if those are two different things. Sorry, I think there is some part of what he says correct, because electromagnetic waves behave partly the same as light. Yes. And so you could use them to either find whether the Earth is flat or a globe. Because they should act the same. But there is a big difference. Light definitely acts different than radio waves do. Light is not stopped by the tropical, how do you call it, the tropical atmosphere, where radio waves would bounce. So I think the most important thing, and I have made videos about that, is if you want to talk about refraction, light bending or not bending, you should understand one thing, that is that on a flat Earth, there is no refraction. You know, the whole thing about refraction is because we have a curved Earth, and light, therefore, moves through different layers of temperature, of different layers of density, and that makes it refract. If the Earth was flat, and I was looking over...
and we're in complete agreement.
I think we are in agreement, but I only disagree a little bit.
There's the visible wavelength, and then going up to the to the terahertz gap, and kind of and working with the electromagnetic waves that are from that terahertz gaps down, which act differently, which is something that was stated specifically several times. But to say that that these are different, I mean, if I'm emitting electromagnetic waves, these are moving as photons. Now, one could argue that, there's a quantum mechanical interaction of photons moving into antiphotons and electrons and
sorry, stop, please.
Hold on 1 second. Go, let him finish his thought, and then we'll let you respond and take every time you need. But let him finish his thought.
Yeah. So what I'm saying is that you're absolutely correct in saying that they act the same way, and it is exactly what we would use to map out a free space. So in a line of sight or something that is, the size of a building or some big auditorium, you can use some, visible light kind of line of sight system. But for mapping out other systems or large areas, you're going to do it with, these type of high frequency systems. Now, the terahertz stuff that I'm talking about is probably a lot less familiar, just because the ways for generating terahertz today is very, very difficult. You're using these femtosecond lasers with, gallium arsenide crystals. And so it's quite difficult. We're actually using these cascade quantum wells and generating them electronically. So we don't have any issue with generating them in focused direction. So they're, again, very, very accurate down to millimeter precision in the work that we're doing.
All right, Gold?
Yes. There is really a big difference between light and all the other electromagnetic radiation. Light can be replaced as a radiation or as photons moving at light speed. All the other electromagnetic radiation that is used in radio communication has a complete scale of different properties. If you look, for instance, at the very low frequencies, and I mean really sub-low frequencies, they can even go underwater and are used to communicate with submarines. The moment you are at what
I'm just
we
not
used to call,
understanding this whole point. I mean, who's going and saying that I mean, there's just been so many points from my side on saying why these frequencies are different and better suited to go and make these measurements, and you're sitting here and trying to explain about the particle duality and different waveform collapse on photons versus RF. I'm just not
that's very
understanding
simple.
the connecting points.
Okay, the connecting point is very simple. I hate flat arts because they come up with all kind of fucking nonsense, and now I have a globe dart who comes up with nonsense as well. Yes,
Okay,
and I
hold on.
hate them.
Now, hold
So
on, hold
I'll
on. Hey,
fight
hey,
any
hold on,
kind.
hold
I
on,
fight
hold on.
any kind of nonsense.
Hold on, M good, whatever
Yeah,
your name is.
Trolling.
There's no,
I'm
he
proud
didn't call
of it.
you names. There's no reason to go down this road of calling each other names. That's not productive in any kind of way. Okay, I get it.
Oh, but
You feel that
not less.
hold
I
on.
did not call him a retard. I call people in general who do this retards.
Oh, okay. I'm sorry.
And
I
I
guess
was
I
not
misunderstood. I
addressing him.
thought you were calling him a globe tard.
No. He is trying his best, but I do think he has somewhere a lack of knowledge.
Well, I
Well,
mean, you
that's
haven't
not an
exactly
argument, though.
connected like particle. You haven't connected the particle duality to his particular argument. Like, how does that exactly make sense to?
I was interrupted because I only got to the lowest frequencies used for submarines.
Okay.
Yeah, the next step,
Can you
we
baseline
know.
your argument? Like, give me a brief,
It's
concise.
an agreement. You know, first of
Guys,
all,
come on.
there's going to be. I hope to learn a lot more to the day I die. There's no argument in the difference in properties between how these photons act in optical, visible, and then once you kind of hit that terahertz gap, changing and then changing more down and down and down. We're not in any disagreement on that. What I'm talking about is the data and what we're able to produce and the clear dead zones that we're able to produce with propagating these electromagnetic waves, this RF at different frequencies, and that some of these frequencies are highly absorbed in the atmosphere, and some of them do not have any interaction and can go over long distances. And yes, we use these evaporation ducts for them to have this nice cushiony bounce so that there's no thermal loss as these waves bounce up and down the evaporation duct. But you can easily remodel that, and you can model, we actually model that, the whole evaporation duct as it goes around the curvature. But still, that doesn't take away from the initial dead zone that happens exactly according to the curvature, which was the only point.
Okay. Now, where do you disagree with that?
Now, if you go high enough with your frequency, he is partly right. But he somehow gathers all the electromagnetic radio frequencies under one category. And that is, and that maybe I'm a stupid asshole who is always tries to be accurate, And if we look at that, the lowest frequencies will follow the curve of the Earth. Actually,
what is the low frequency for you? What are you talking about? What frequency?
Hold on.
What they use
let
for
him finish talking.
Yeah, so low frequencies is way below a couple of 100 megahertz. Yeah.
Yeah,
we used to have radios which had low frequency, mid frequency, and UHF. Do you remember that time? FM frequency modulation, does that ring any bell? AM,
yes,
does that ring any
remember
bells?
the 80s.
But you're still talking about something that I'm not talking about. I'm not talking about anything that is in the single megahertz or below, and I'm not talking about amplitude modulation versus frequency modulation Either I am talking about even just looking at the signal to noise ratio, dB loss over these distances, and being able to create a vector out of that and being able to see the dead zone. And I'm talking about much, much higher frequencies. And secondly, the other point that you said that I've lobbed all the frequencies together, tell me one time where I've said that. I've talked about very high frequencies and a certain subset of some high frequencies, which I plotted. There was some data that was plotted by some of the different publications that we were working with. So, I mean, nobody is putting all the frequencies together or making these claims.
Oh,
so, I mean, you're just speaking to claims.
I can't keep up with your word salad.
What
hey,
works?
Hey,
Are you trolling?
Can we please stop?
No. Come on, guys. If you knew my channel, you knew I haven't done enough stuff. I'm not trying to troll anybody. I'm trying to be accurate. And I've been listening.
Other than
Where is he
being
wrong?
just pedantic and nitpicky at this point, like I don't understand what you're even trying to dispute about his argument. Like
Right.
I don't like it. Just seems like you're just latching on to small points where you think that he's not as precise as you would be. That's fine if you want to be more precise or whatever you view that as. But you haven't actually presented anything yet to show how he's wrong about anything.
That is because I've joined your discussion or probably somewhere halfway. And then I was just amazed about the word salads that were spread out as if I was listening to a flat earther. And then I finally discovered, okay, he's not a flat earther. He's trying to prove somehow the globe. But a lot of the stuff he was
I'm gonna give you one last shot.
was not
I'm gonna give you one last shot to say where he's wrong. I'm gonna give you one last shot to say where he's wrong, and then we're gonna have to say goodbye. So here's your one shot. Make it good.
No, one shot, as simple as that you cannot use any radio frequency and then say that is the same as photons as the frequency of light. There is no proof. Never ever. I've seen.
No, look,
no.
It's all electromagnetic radiation, so I don't even know what you're even talking about.
No, godless, you know better. If we work in physics, sometimes we use photons to have certain properties, and sometimes we have to use electromagnetic radiation as a property. Those are not, by definition, exactly the same. It's really not true. A photon.
Are you saying that visible light is? Hold on, let me interrupt. Are you saying right now that visible light is like not just on a different part of the spectrum of electromagnetic radiation, but that like visible light is a completely separate entity to electromagnetic radiation in general?
No, what he's saying is it's a subset, and it does have some specific set of properties. And he's talking about just putting that, you know, or saying that, 500 megahertz EM propagation is the same as photons at 800 nanometer wavelengths, or going into the UV. And of course, even going into the UV, there's, you know, exactly what Max Planck, you know, solved as far as the complete change in properties. But I was just, I guess maybe the first part of the conversation you missed was focusing on a few different frequencies that we used in this exercise of being able to find the dead zone and map out the curve. So what you heard of hopping through different frequencies was me just talking about the selection of different frequencies due to their properties with interacting with the atmosphere. And then, of course, moving into terahertz, the interaction with oxygen, which is, of course, where you're getting the heavy loss.
Yeah, but the interaction with atmosphere is something that already gives me some goosebumps, because I don't think it is interaction with atmosphere as such.
Sure. Okay. But again, irrelevant to this conversation.
Yeah, well, that depends. You know, you have frequencies that follow the curve of the Earth. Those are the lowest frequencies, and then slowly go up and then they start to behave like light, an magnetic field that just goes straight over the curve into infinity, into space. And then there are frequencies that start to bump off the ionosphere. And then you have higher frequencies that again go straight through this sphere. And then you have light.
So when
and with light,
You literally repeated
especially-
everything I said in the beginning of my conversation.
right, that's why.
But
he
let me ask
picked
you
the
so
this:
that-
if
specific
you
that is
take an
nice,
emitter,
the
if you
moment I
take an
joined,
emitter and you emit, if I take an emitter right now, like
Yes.
a 4G or a 5G emitter, and I place it 1 meter over the ground, will I have a dead zone at a certain point?
Mhm, definitely.
That was the only
That
point.
is
Thank you very
why
much.
the higher the frequency goes up, the smaller the grids are of
Good,
all
so you agree.
the mobile stations. Yes.
So you agree? Perfect. Okay.
Listen again, we both are on the same side with regard to the globe. But I heard
Mhm.
you talk a lot about a lot of stuff that I thought, okay, this it's just not accurate enough, you know. You say measurements go above math. I think I heard somewhere, or calculations, and I think no. If you do the math correct, the math and the practical stuff we measure should be always the same. That's my experience in
Yeah, I mean that's
33
exactly what I
years.
said. I just don't understand what conversation you're referring to. It seems like we've just
Well,
listened to two
sorry.
completely different conversations.
Gould, why don't you?
Well, that is the impression I got when I listened.
Hold on, everybody. Hold on, everybody.
Yeah.
Let's do this.
Sorry.
Gold, we're going to give you the opportunity to go back and watch this again. Gather any points that you after watching it, and if you still think that there are points that you need to bring up, he said he would agree to come back. We'll bring you both back on, and you can stake them. That way, you know exactly what was said, and there's none of this, kind of having to suss through it and find out that we all agree at the very end anyway. Because we do have to let him go. It's late there. This was last minute. We
yes.
literally just put it together.
Yeah, but
couple
here
hours
it is
ago.
4 o'clock in the evening. Eh? It's 4 o'clock in the morning, so I'm really.
I'm sure.
also from
I'm sure,
your-
but when you
I
don't
want to
plan
give
for
you one
that,
thing to think about.
when you don't plan for that, it kind of fucks up your entire next day. So I'm not going to be rude
I know.
and
I
extend that out to him.
understand. May I give you one thing to think about?
Of course.
Do you know that there are circumstances in which light would follow exactly the curve of the Earth? And that means that in such a case, any measurement done with trying to do with a laser or whatever is therefore stupid, because if the atmospheric conditions are correct, you can go over 100 miles and still think you have a flat Earth while you're looking over a curve.
Fully, absolutely, 100% agree. That was the whole premise of my discussion.
Okay, man, we like each other. That's nice.
So that was the
Good.
whole point of the whole first part of what I was saying, of going
Sorry.
away from that. And if it didn't act that way, then the systems that we're doing for tsunami detection and using the evaporation duct system as a waveguide wouldn't work. So I just don't know what we're
Yeah,
disagreeing
that's
on.
the thing we should
maybe I'm
discuss
just too tired.
between each other, because it has nothing to do with the globe or flat Earth. But that's another one I would like to discuss with you another time. But I thank you
We're
for
gonna let-
letting me in, guys. Really.
Sure. And thank you both for coming on. Hang tight with us, everybody, because I'm going to have Dave read super chats here in just a second. But thank you, Aiel and Gold, for coming on. And Dave, we can go ahead
Like
and
your show,
start reading
guys.
those.
Really.
Thank you.
Yep.
Big supporter. Bye-bye.
Bye.
Bye.
Did he go? Okay. Anyway, I'll just go ahead and read them. 82 Japanda. First live stream I wasn't at work for, so happy. Hi, GE. Sadie79. Hugs. J Dragon Malay. Happy wedding day to KC and JE. All the best to you both. Kirsten Frost
Thank
laser
you.
beams. I fell off the edge. Uncle Ned. Checkmate, Globe Deniers. Jay says, I was in the pool. Just trying to do you justice, GE. What happened? Where'd Kyle go? I guess he had to go off camera for a minute. Scrat, the
I think
skeptic
so.
squirrel. M. Goodsmiths doesn't understand the application being used, was my guess. Yeah, I think that's where the disconnect was. He came in after he started because all that was explained up front, and a couple people had the same issue. Mark Beiser says, M. Goodsmiths, thank you for wasting all of our time because you got here late and didn't see that. He already said all this. Well, he didn't know, so Mark, give him a little slack here. And that's it, John.
Okay. Yeah, so I appreciate everybody joining us today. Like Kyle was saying, it was kind of a last minute kind of put together, and we really appreciate IL. Is that how you pronounce his name? You know how I am with names. I can't remember. It was really great for him to come on, and I had a great time tonight. I'm gonna have to go back and re-listen to what he was saying because I was trying to follow along, but I think that the whiskey was getting in the way. But I do have to say that one of the arguments that I have the hardest time with is the argument that a lot of people put towards me, and that's, oh, you're not precise enough, or I think that you need to be more precise. I think there's a way to communicate on a very basic level these complex ideas so that people of any kind of understanding can learn or understand what you're saying. And to complain about somebody's precision, I feel, is really kind of like, oh, this is not how I would explain it, therefore they're wrong about it. And I don't feel like that's very productive to the conversation. I mean, if they say something legitimately completely wrong, fine. But to nitpick at somebody for not being as precise as maybe you would be, or maybe you missed out on the conversation or something like that, I mean, I don't know. I feel like that's very, very nitpicky. And, I don't know. I don't really like it when people resort to that because there's no actual argument against what you're saying. It's just like, oh, I would have done it differently. Well, of course you would have done it differently. But yeah, so Kyle, you got any final thoughts?
I thought he was still here. You were talking to him. Sorry, I'd ordered some food. My delivery came. I had to go get it real quick.
Oh, okay. What'd you
By
get,
the way,
Chinese?
I got fried pickles and a little thing of the soup that they have there. But here's the funny thing. So I had put it for an hour and a half. After I had scheduled it to go through like an hour and a half. Well, I forgot about it, and it sent. And here I am again in a shirt and a jacket and underwear.
Answering the
Yes.
door in your underwear. God.
You don't have time to think in that case because you're in the middle of something, and I'm like, okay, I've got to let them know that I'm have to check out real quick, and I didn't have time to think about what I'm wearing. I just needed to get to the door and then back quickly, and yeah. Yeah, I've already done super chats. Dave, did you get that last one that just came in?
I don't think I did. I think I was going to do that.
I'll get
after
it.
we had a little...
I've missed you guys.
I can read it real quick. Oh, go ahead, Kyle.
I've missed you guys so much. Flat Earth will never be dead. If they are to the point of denying math and the results of their own experiments, they are a lost cause or dishonest as fuck. I think you're accurate there. But at least we can say that they died here in terms of people willing to come in and try. Of course, they'll never the movement will never die. But here tonight, at least one argument died. I think we can. Here's what it is. We can say that the water always finds its level argument is dead. That's a better, more accurate way to put it. Don't you think, GE?
Mm-hmm. I think so.
Cool. Well, there will be no Saturday night next week on Saturday because I, of course, will be officiating a wedding next week. Are you guys excited? GE?
Yes. We're
Yeah.
definitely excited. We can't wait to see you and have our special stream on Friday.
Yep,
And
I was
then
gonna say that.
huh?
I was going to say we're going to be doing it next Friday night. Will be on Friday. So
Yeah. I can't wait for that. So it's gonna be exciting next week.
we will be together in on the same location. So you will get GE and KC all from one place. So that's going to be really cool. As always, thank you guys.
I gotta find all of my webcams.
Oh yeah, I didn't even think about that. We'll just all smash in together one frame.
Yeah.
As always, thank you guys for joining us for this Friday night. I think this was amazing information, and I'm glad that he was able to stop in and share it. We will be back tomorrow with. I know Nunbot is. I took Nunbot. She's still counting your points. I took her off though because, like I said, I'm going to start doing it where the Nunbot's active in terms of finding out your points and redeeming things on Monday for the first 10 minutes, and then when the super chat thing opens. That way, the chats, when there's conversations and I'm needing to see like if people are asking questions or anything like that, it's not flooded with all that the point stuff. So she is still counting your time here. She just is not responsive to keep from clouding the chat up. Okay, so we'll see you back tomorrow here at 8 o'clock with me and Jimmy, and then at 9:30 with Katie Paulson for the Smoking Nun. And have an amazing Sunday fun day. Good night.
Sunday fundy.
Sunday fundy.